Okay, this is one of our teaks, and it's 85 D. Recognize that chemical formulas are used to identify substances and determine the number of atoms of each element in chemical formulas containing subscripts. So we're going to talk a little bit about our subscripts. So 85D. Well, we already know that H2O is a formula, right? That describes a substance, and we know the substance ought to be water, right? Well, in this formula, the little 2 is our subscript. The subscripts are always smaller numbers, and they always go with the element in front of them only. So if I were to count elements here, I would have H equal to and O equal to, because both H and O are in this formula. So I know H has 2. There are 2 H's, because it tells me the subscript says there's 2. And O, well, there's only one O listed. There's no subscript, so it's only that single one. Okay, let's try this again. Let's try it on something a little bit more complex. How about glucose? C6H12O6. And this is glucose. This is a simple sugar the plants make during photosynthesis. It's not the sugar we eat, unless we're eating fruit, but it's not table sugar. Alright, so let's see. We see that there are 3 subscripts now. This one goes with this one, right? Always the element in front of it. H has 12 going with it, and the 6 goes with the oxygen. So let's once again try and count how many elements. There are 1, 2, 3 elements, right? Carbon, hydrogen, oxygen. Now let's look at how many atoms of each element there are. So there are 6 carbon, 12 hydrogen, 6 oxygen. These are the atoms, and these are the elements. Please make sure when you're reading through a test that you read carefully. They're always going to try and trick you and ask you about one or the other. And if you're not paying attention, I promise you will miss it. Remember, elements, periodic table. Those are those letters on the periodic table, right, that represent the elements. Atoms are how many of each element. Okay. So much for subscripts. Now, on this last test you took, it was a little tricky because you did have some double subscripts to contend with. So let's look at that and what to do when. I'm going to take one straight off the test. So we had an example of CO, parentheses, NO, 3, double subscript 2. Alright, first of all, let's count the elements. What are elements here? Okay, so we have CO. Remember, small letter following a capital letter lets us know that that is still one element. That's its symbol. So we have CO. We have another capital letter N. And we have another capital letter O. So these are our elements. So let's figure out how many atoms of each. So we want to know how many atoms of each of these we have. So CO is all there by itself. There's no number next to it, no subscript, indicating that there is only one. N is stuck in this parentheses, and if you know from math, you always do the parentheses first, so you could even actually remove these by multiplying the subscript 2 by the elements inside the parentheses. So we could bring this down and say N. Well, this goes with everything now in this parentheses, right? So N2, and O was already 3. Now we have times the 2, so that would be 6. So now we could finish our job and count the elements. So we have 2 nitrogen and 6 oxygen. Okay, let's practice one more real quick. How about this one? NH4, double subscript 2, and PO4. Okay, so we're going to go through once again, and let's start with listing our elements. Okay, N, H, P, they're all capital letters, so there are 4 capital letters. They're all elements. All right, now let's look at how many atoms. Alright, so we're going to dissolve the parentheses before we move on. Remember, this parentheses says multiply by this little subscript 2, anything held within it. So that will become N2, H, 8, P, O, 4. Now we can just straight count them. So we have 2 nitrogen, 8 hydrogen, 1 phosphorus, and 4 oxygen atoms. If you have any questions on how to do this, please make sure you ask your instructor.